All right. In this paper 2018, February, March 22, there are some questions to cover basic stuff that we have learned in at the very first part of the syllabus. In the first question, we have ionization energy related questions. The graph shows a sketch of the first ionization energies of 6 successive elements in the periodic table. Even though the word successive word comes, it's not successive ionization. This is about first ionization energies of 6 successive elements in the periodic table. Do you remember? First ionization energy graphs. First ionization energy graphs, they take a kind of a specific pattern. If you start from hydrogen, hydrogen first ionization is a little bit high. Helium is very much higher. When you go from helium to lithium, this successive first ionization energy comes down to a lesser value. And then across the period, from lithium to beryllium, it goes up. And for the third element, it comes down a little bit, goes up further, and then comes down a little bit, and goes up twice. This is for helium. When it comes to helium, this is lithium. And this one is neon. Always at higher places, the peaks we have noble gases. After noble gas, you come down to a very low value for group 1 element. This is sodium. See the relative question. And the same pattern is there. But when you go to a helium, neon, argon, see the first ionization goes on decreasing for elements when you go down the group. Now this is lithium. This is sodium. And potassium will be somewhere here. Potassium. So this sort of a structure we have studied for first ionization energy patterns for consecutive elements. And here we have a similar thing, A, B, C, D, E, F. There are 6 consecutive elements. We don't know to which group they belong, but we had to figure out how. Look at this first ionization energy of A. It's a high value. From that high value, we go down to a really low value for B. And then you go up a little bit and then slide down and up and up. This diagram shows that A is a noble gas. This is a noble gas. And B should be group 1. Explain what is meant by the term first ionization energy. Different children write different things, but for the same idea. I can write one definition for the first ionization energy. It is the energy change involved. It is the energy change involved when 1 mole of gaseous atoms It is an energy change involving 1 mole of gaseous atoms change to 1 mole of gaseous unipositive ions by removing 1 mole of electrons. This is 1. I can modify this answer a little bit to write the second answer. Actually, it's the same thing. In the exam, we can write one of these, not both. It is an energy change involved when 1 mole of gaseous atoms change to 1 mole of gaseous unipositive ions by removing an electron from each atom. Oh, gaseous unipositive ions by removing 1 electron from each atom. Learn both, but write only one. Suggests why the first ionization energy of B is much lesser than that of A. See, A, B. A is a group 8 element, noble gas. B is group 1 element in the next period. So definitely when you go from the noble gas in one period to group 1 in the next period, if the noble gas has a size like this, the group 1 just after that noble gas has a big atomic size where there's one energy level is more than in noble gas. So here we have, because of increase in energy levels, we have a higher shielding effect. SE means shielding effect. And also the distance between the nucleus and the outermost energy level also is higher in group 1 than group 7 or group 8 in the previous or last period. So radius is increasing from this noble gas to this group 1 element, and also this group 1 element in the next period has a higher shielding effect also. Because of these two reasons, the size increase and the increased shielding effect, outermost electrons are attracted to the nucleus less strongly in B. That has to be given. I'll write the answer like this. E is what? A is noble gas and B is the group 1 element in the next period. He has one energy level. B has one energy level. B has one energy level more than in A. Hence, the outermost electron, outermost electron in B is further away from the nucleus, than in A. That is one thing. Next one, due to increased inner energy level, due to the increase, I'll write like that. Due to the increase of an inner energy level, due to the increase in an inner energy level, comma, the shielding effect in B is greater than in A. Because of these reasons, the outer electron in B is loosely bonded to the nucleus. Hence, outermost electron in B can be removed easily using a smaller amount of heat energy. You need to practice these writings if you have to score good marks. See, 3 marks. Don't think about the amount of writing as long as you are going to get the marks. So it's a very expensive answering system here. We go to the next one. P to T are successive elements in period 3 of the periodic table. Now, there's another graph now. And they are also successive elements, means they come one after another. After P, we get Q, afterwards R, S, T, it comes like that. The letters are not the symbols of the elements, okay? On the axis, sketch a graph to show the trend in the atomic radius of the element P to T. Explain your answer. If the question says that they are period 3 elements, this is easy. When you go across a period, any period, atomic size decreases. This is a graph. Atomic radius decreases. Now we have to give a reason as to why atomic radius decreases across a period. Before going into that, I'll just try to remind you, when you go across a period, if this is a periodic table, when you go across, the size of particles, atoms, decreases. First, we have to remember this fact, and afterwards we can go for explanations. Size decreases, but moving down the group, size increases. So we can expect the smallest particle to be here and the biggest element to be found over here. Okay. Now we'll give an explanation. This explanation is for this pattern. Why atomic size decreases? We'll write the answer. Moving across a period, come on. The number of energy levels. The number of energy levels remains the same. Shielding effect also remains the same. Next point. However, moving across, the nuclear charge, the proton number increases. Proton number, hence, the effective nuclear charge increases. Therefore, the number of protons, hence effective nuclear charge increase. Therefore, the nuclear attraction Therefore, the nuclear attraction towards the outer electrons increases. And they are pulled more towards the nucleus. And the size decreases. The answer Manav gave for this question is perfect. You get full marks for that. Okay, this is how we analyze a question and construct answers to show the variation in ionization energy, especially first ionization energy, across the period. And variation in atomic size also can be explained in the same manner, the way how I explained. If you have any doubt, you can ask from me. Otherwise, I think I can finish the discussion. This is question number 1 in 2018, February, March, paper 22.